Okay, so parent functions are 12, nothing more than some basic functions that commonly appear in mathematics. Okay, so I feel like this is, interestingly enough, something that never really gets taught sort of like as a collection of functions. And so students kind of know like a little bit about this one, a little bit of that one, but we don't always recognize like things that happen to all of them. And so that's what our goal here is, to kind of make sure that we know the basic shapes and how they apply to graph transformations, but also to take a look at things like domain and range and asymptotes and end behavior. Okay. So in the STEM core math sequence, we're going to focus on the list of functions that's in the chart below. Okay. So I did include some extra ones, the greatest integer function, as well as something called the logistic function. But I just want to show them to you. I want you to know that they exist, but we're not going to be responsible for knowing the greatest integer and the logistic function. They just don't happen as much in our math sequence, okay? But here's sort of like the breakdown of what we know, what we're learning, and what we're gonna learn. Okay, so from pre-MESA, I hope that we all know what f of x looks like, f of x squared, the absolute value of x, and the square root of x. Okay, so those are ones that I hope you've seen at some point in your academic career. Now, what we're learning in Math116 is we learned already about our exponential one, our e to the x, our natural log one, our natural log of x, and we're going to, in the next section, learn about x cubed and 1 over x, okay? So by the end of Math 116, there are 8 graphs that I want you to know super, super well. So if I'm like, hey, I want you to graph e to the x, you know exactly how to sketch that graph. And you know that it has a horizontal asymptote. Whereas if I asked you to graph the natural log of x, you'd be like, oh, I know it looks like this, and I know it has a vertical asymptote, okay? Now, just to kind of look ahead, because we are in this together for 16 weeks, what we're going to learn in Math 104 is we're going to take a look at the last 2 parent functions, so cosine and sine, okay? All right, so that's sort of a little blurb about where we're headed. So in this packet, I've included a little picture of every parent function, a list of characteristics that we want to focus on, and then sort of like a list of like, here's the domain, here's the range for all of our parent functions. You're welcome to, I wanted us to kind of have it all in one place. If you're a flashcards person, this might not be a bad thing to put on flashcards and kind of drill yourself on. That might not be a bad idea, okay? All right, so this page is a great one. If you happen to have a printer, you could certainly print these out and then just write on the back of them what the domain and range and all of those, and create your own flashcards from here, okay? But here's a brief overview of all the different pictures that I want us to recognize and be able to plot fairly quickly. Okay, now the number of important points is going to be a little bit different for all of them, but all of them will have the same idea of a center point that we're going to use to help us with graph transformation, okay? All right, so I did also include a list of the characteristics that we're going to take a look at, okay? So for every equation, I want us to know the name of the equation. I want us to know the equation of the equation. And I know that sounds silly, but sometimes we're like, x squared, I don't really know what the name of it is, it's just x squared, but we want to make sure that we know the names of these functions as well, okay? We're also going to be taking a deeper look at domain and range. I feel like that's something that we want to know how to find, okay? So I put some questions here that you can kind of ask yourself, but when you're looking for domain, all right, what you're looking for is it's the set of all input values, okay? So what kind of values can you put into the function? And if you're not sure how to find the domain, here are some good questions to ask yourself. Can you put in positive values, negative values, or 0? Okay. And can you put in integer values or fractional values? So we're kind of grouping numbers into types of numbers, and that often helps us determine what the domain of a function is going to be, okay? Similarly, the range is going to be all output values. Now, with the output values, we can kind of ask ourselves the same questions. So can positive values come out? Can negative values come out? And can 0 come out? And then can integer values come out and can fractional values come out? Okay. And those answers will help us determine domain and range. Now, the horizontal asymptote we've seen in our exponential graph, but one connection I want us to make here is that this exponential or this horizontal asymptote is actually connected to the domain of a function as well as something we call the end behavior, okay? So we'll know that a function has a horizontal asymptote if the left or right ends of the function look like they flatten out, okay? That's why I was really picky about like the log graphs. We don't want that to flatten out because it doesn't have a horizontal asymptote. It actually kind of keeps going up forever and ever, okay? Now we can kind of take a look at the same thing for the vertical asymptote. So if the horizontal asymptote deals with the domain, the vertical asymptote actually impacts the range of the function, okay? So we know that there's a vertical asymptote if you look at the graph and there's an x value that does not have a y value, meaning there's no point there, okay? There's almost like there's something missing. And the y values go to positive or negative infinity from either side of that point. So it kind of goes up or it kind of goes down. That's an indicator that we have a vertical asymptote, okay? Finally, we're going to take a look at the shape, and by shape, we're going to look at symmetry, okay? So symmetry, we can talk about in a few different ways. Symmetry can happen across the y-axis, and if a function is symmetrical about the y-axis, we call that an even function. If a function is symmetric about the x-axis and the y-axis, then we call that odd. And if it's not even and it's not odd, then we just say it's neither. There's no special name for that, okay? All right, and we've got this something we call end behavior, all right? So the left end of the number line, if I think about a number line, okay, and here's 0 in the middle. If I go to the left, what number am I getting to? Yeah, I'm going to negative infinity, okay? So instead of a question mark, let's put negative infinity. So left end behavior says what happens as we go to the left end of the graph. And here are some options. We might see that our graph goes up, and then we just say that the end behavior is up, okay? We might see that the graph goes down, and then we'll say that the end behavior is down. Or we might see that it actually flattens out to a number. And then that will be the number that we say the end behavior goes to. Okay. Now, if we think about this same number line and we have 0, if we go to the right end, we're not going to get to negative infinity. That would be silly. We get to positive infinity, all right? And this positive infinity is our right end behavior. And our options are the same. We might see that the function goes up. We might see that the function goes down, or we might see that the function gets to a number, okay? So this is just a little chart to kind of help you keep track of all of the vocabulary, but I think it's always makes it a little bit easier to remember all the vocabulary when we practice it in the context of the question, okay? So we're gonna take a look at the identity function today, the squaring function, the square root, and the absolute value. So those will be the 4 functions that we take a look at today. All right, so let's start off with the identity function. So the identity function is nothing more than f of x equals x, okay? So what is the point that is on that graph? Someone give me a point that is on that graph. 0, 0. All right, so 0, 0 is on that graph. We might even consider 0, 0 to be sort of our center point, okay? Now, what other points are on this graph? Okay, so we've got 1, 1, 2, 2, 3, 3, 4, 4, 5, 5. And we could go in the negative direction. -1, -1, -2, -2, and so on and so forth. Now we can go ahead and connect these with a straight line. Okay. All right, so let's start with the domain here. Are there any x values that you cannot put into the equation? Like, can you put positive numbers into this equation and get a number back out? Yeah. Can you put negative numbers in and get a number out? Okay. Can you put 0 in? That one we know for sure because that was the first one. Can you put fractions in? And can we put whole numbers in? Yeah. So that means our domain is going to be from negative infinity all the way to positive infinity. Okay, there's no value that I cannot put in, so we say that our domain is from negative infinity to positive infinity. Okay. All right, what about the range? What kind of numbers can come out? If we put in a number, can we get a positive number out? Yes. Can we get a negative number out? Yes. Can we get 0 out? Yes. And we could get fractions out, right? If we put 1/2 in, we're going to get 1/2 right back out. So since the answer to all of those was yes, we can say that our range is also negative infinity to positive. Okay. All right. So before we move on to the asymptote, let's look at the shape of this. If I were to fold this right over the y-axis, is the right half going to match exactly with the left half? No, okay? So since the right half will not match with the left half, we know that it is not even, okay? And we could even say right half does not match. Oh, left. Okay. Does, if I sort of reflect it over the orange line and then over the green line, does it match? Yeah, it does, right? Because if I reflect it over the orange line, I get like something like this part becomes this. And if I take that and I reflect it over the green line, I get that bottom part. So in this case, let's see, what color did we use? We didn't. Okay. In this case, this function is odd because it is symmetric about x and y axis. Okay. And you might also hear it described when it's symmetric about the x and the y axis. Sometimes we call that symmetric about the origin. Okay. So symmetric about the x and y axis is the same as symmetric about the origin. So we know that the identity function is actually odd. Okay. All right, so we've got domain, range, even, odd. All right, now let's look at this. Are there any horizontal asymptotes? Like, does the curve flatten out at any point? No. Okay. Are there any vertical asymptotes? Does it kind of go straight up at any point or straight down? No. Okay. So I included those here because some of the functions we're going to look at have horizontal and vertical asymptotes, but this one we can say is not applicable, or NA. All right. So there are no horizontal and vertical asymptotes for our identity function. All right, now tell me about the left end. When we look at the left end of the function, does it go up, does it go down, or does it get to a number? Okay, I've got one vote for down, 2, 3. All right, yeah, if we take a look at this part of the graph, it sure does look like it's going down. So you can write it as down, or you can simply put an arrow facing down. Okay, either one is fine. What about the right end of this function? What can we say about that end behavior? It's going up, exactly. All right, so we've got up on the right, or we can say arrow up, and then left end behavior is down. Okay. So a newer way of looking at our identity function. All right. Any questions on the identity function? The origin and the center point is the same for this function, but if we think about our exponential or log one, it's not the origin for those, okay? So sometimes it is the origin, sometimes it's not. Ooh, okay. All right, the squaring function. Guesses as to this equation. What is the equation for the squaring function? All right, x squared, good. And when you're writing these on your own, you want to make sure that you're writing that f of x part, right? We want to make sure we're doing good with our notation. So we've got f of x equals x squared. All right, give me some nice points that fit on this curve. What are some coordinates that are on this? All right, 0, 0. Okay. We've got 0, 0, 1, 1, 2, 4, 3, 9. All right. And give me 3 more nice points that fit on this grid. Same ones, but negative y. I'm going to disagree with that. Negative x, yeah, negative x. Okay, I'm pretty sure that's what you meant. Negative 1, 1. Negative 2, 4. Negative 3, 9. Okay, good. So now we can connect these with a nice smooth curve. I always get so nervous drawing these. I feel like my hand shakes a lot. But, you know, practice makes perfect. Okay, so we've got our good old friend x squared. Okay, so tell me, folks, is this one symmetric about the y-axis? Yeah, it is, right? When we fold, what color did I use? Orange. When we fold this function over the y-axis, the left and the right half match. So that means that we've got a case where it is even because it is symmetric. About the y-axis. Okay? That's kind of one thing that makes it special. All right. Now, let's talk about the numbers we can input into this function. Can you put positive numbers in? Yes. Can you put negative numbers in? Yes. Can you put 0 in? Can you put fractions in? Yeah. Okay. So since you can put any kind of number into your function, our domain is going to be negative infinity to positive infinity. Okay. Now let's take a look at the range. Can you get a positive number out of the function? Yes, you can get a positive number out. Can you get a negative number out? No. Okay. So immediately I know that the range is not from negative infinity to positive infinity. Okay. But can you get 0 out? Yes. Okay. So the way we write that, we have to pick the smallest number first. So 0 is the smallest number it can be, and it goes all the way to infinity. Good. Okay. Now we can never get to infinity, which is why we use the parentheses. So if you're looking at positive or negative infinity, you should always have a parentheses. But since you include 0, we use a bracket. And this bracket says that we include 0 in the range. Okay? So if we use a bracket, it means that that point is on our curve. Whereas if we use a parentheses, it means that it's not. So when we looked at exponentials and logs, we did parentheses, but with some of the other ones, we use a bracket because we actually can draw that point on the graph, okay? All right, tell me about vertical asymptotes. Are there any vertical asymptotes for this function? Oh, okay, David, great question. What's the difference with domain and range? Domain is your input values and range is your output values. Does that make sense? Yeah, input being the X and then output being the Y values, okay? All right. And domain is left to right and range is bottom to top, okay? All right. So Richard said there is no vertical asymptote. I would agree. It doesn't go straight up at any point. And then with the horizontal asymptotes, does it flatten out as we go side to side? No, it doesn't flatten out. So we also have no horizontal asymptote, okay? Now let's look at that end behavior. Sorry, trying to keep the colors consistent here. Left end and right end. What are our left end behavior and right end behavior? Up and up. Good, right? Because both ends go up. So we can say here that it's up or an arrow, and this is also up or an arrow. All right? So there's our squaring function in a nutshell. All right, let's take a look at the next parent function. Absolute value. All right, what's the symbol for absolute value again? Yeah, it's those bars, okay? So if I write bar x bar like that, that means absolute value. Okay, so someone give me some points that are on this particular function. One, okay. So I zoom in, I can graph that point 1, 0, 0. Ah, okay, is it -1, -1 or -1, 1? -1, 1, yeah. All right. What happens if I put in 5? What y value comes out? 5. What happens if I put in -5? I get 5. Okay. So remember, the absolute value means that we just change the simplified thing inside the bars into a positive, all right? So does this function look more like the identity function or the squaring function? What do you guys think? Okay, Laura, tell us why you think it looks like the squaring one. What features does it share? Yeah, kind of like both combined, right? What features does it have from the squaring function? It's even. All right, I buy that it's even, right? Because if we draw in our y-axis, we know that it is symmetric about that. So we can say it's symmetric about that. Good. Okay. It does not have negative y values. Okay, so what does that mean about the range then? What can we say for the range? Yeah, it's going to be bracket 0, comma, infinity, parentheses. Beautiful. Okay. What about the domain? Tell me about the domain. Are there any restrictions, things it cannot be? No, we can put in any kind of number we want. So our input or our x values are going to go from negative infinity to positive infinity. Okay. Um, any asymptotes here? Nope, no asymptotes. All right. And tell me about the left and the right end behavior. Got the left end and the right end. Uh-huh. Both of them are going up. Good. So up, or draw the arrow, up, or draw the arrow. Okay. So it is kind of like the squaring function and the identity function had a baby, right? Like it's got straight lines like the identity function, but it has a lot of the same features as the squaring function. It's even, it has a range from 0 to infinity, and the end behavior is the same as a squaring function, okay? Ah, great question. End behaviors are exactly, they tie into limits and they explain one type of limit. Yes. Okay, so this up-down notation is going to be where we start, but by the time we get to February or whenever we start Math 150, then we're going to be talking about it in a slightly more grown-up way, okay? But I wouldn't worry about limits right now. All right, so Eric, don't worry too much about that. Okay. All right. We've got one last parent function for today, and that is the square root function, okay? So the square root function, we can take the equation exactly from the name. We know it's going to be f of x equals the square root of x, right? And so let's pick a few points that we can plug in for x to think about creating a graph. So one of the points I usually start with is I try plugging in 0. So if I plug in 0 for x, what do I get out for y? 0. Yeah. So 0, 0 is a point. Okay. Maybe let's make a little table here. Ah. All right. So x, f of x, 0. Okay. Plug in 0, I get 0. 4, 2. All right. How come you didn't try plugging in like 3? Should we try plugging in 3? Yeah, so it's going to be what we call an irrational number. But keep in mind that irrational is not the same as an I, okay? So when we look at the 3, it's more just that the square root of 3 is not a nice number. So if we're graphing this by hand, it's kind of silly to try and graph decimals, okay? So I think 4 comma 2 is a really good point to plot. No, sorry if I wasn't clear. What other numbers could I put in so that the number I get out is a nice number? 9. All right, 9. I plug in 9. I get 3. Good. Okay. What else would be a nice number to plug in? 1. Yeah, when I plug in 1, I get 1. Okay. Now, I left a lot of room at the top of my table because typically we're like, oh, we try like the negative values too to make sure that we get both sides of what we need. Okay. But if I plug in -1, and I think Natalia, this is where you were thinking about, if I plug in -1 and I try and take the square root of -1, I actually get an imaginary number. Okay, so I get something we call I. What if I plug in -4? What's the square root of -4? Close. Mm, good, yeah. So the 4 we can actually take a regular square root of, and then it's 2i because it's the negative. All right, yeah, there you go. All right, what about the square root of -9? 3i. Okay, cool. So these are things that we call imaginary numbers. All right. And we'll deal with those in unit 2. All right. So we're not going to worry about them for right now, but I wanted to kind of refresh our memory and kind of think like, okay, do we remember what our I stands for? Okay. So is there a question? Undefined because no number square. Right, right. So we could say that if we're trying to graph it, these are imaginary numbers. And one thing that Natalia said in the chat was that we cannot plot imaginary numbers on a real plane. So we have x and we have f of x, and we consider those to be real. So I can't actually plot I and 2i and 3i. Okay. Yeah, Brian, how could you? Um, all right, so if I connect the points that I have, this is what our square root function looks like, okay? So it's like a sideways parabola, but it's only the top half, okay? So it's like a sideways parabola, but only the top half. So talk to me about whether this is even, odd, or neither. And how do you know? Yeah, it's going to be neither because there's no symmetry, right? If I fold it over, whoa, if I fold it over the y-axis, there's nothing that it's going to match with on the other side. And same thing if I fold it over the x-axis, there's nothing to match it. So we can say that this one is neither, okay? Because it has no symmetry. All right. Domain. Domain is our x values. Domain is our input. What's the smallest number x that we could put in? Zero. Okay. So remember when we write when we write when we write our domain, we have to go from left to right. So we need the smallest number first, and we can put 0 in. So we're going to use a bracket. And then the largest number we can put in, it goes all the way to infinity. So our domain is something we call restricted. It only goes from 0 to infinity. Okay? All right, what is the smallest y value that can come out of the function? 0. Okay. And it's going to be the same as the domain. Yeah, our range is going to go from 0 all the way to infinity because we have everything above the x-axis and including the x-axis. All right. All right. Any asymptotes? Nope, no asymptotes. So N-A, N-A, okay? And left end behavior, we're thinking, what happens when we go to this end of the graph and there's nothing there? There's no graph there. So we say that, yeah, there's actually no left end behavior, okay? Because the graph doesn't go to negative infinity. But the right end behavior, it's going up, okay? So one thing to note here is in our picture, it is going up kind of slowly, but it's still ultimately going up. So we want to call this up, okay? It's really important to note here that it doesn't flatten out. Like the more you go out, you can still keep getting larger and larger y values. They just grow very slowly, okay? All right, so that's it for the parent functions right here. So what we're gonna do is this. Let me stop sharing the screen. Where did you guys go? Okay. So what we're going to do is this. I am going to say, let's practice a few of these parent functions with graph transformation. Does that make sense? So we're looking at the parent functions, but we're going to practice doing graph transformations with them like we did with our exponential and our log function, okay? This is sort of a last minute change, so I do not have a worksheet for this. So we're just gonna kind of like, yeah, the same rules apply. So I'm just gonna pull up a blank note on my Notability, but I'll also post that on Canvas so we'll have it to look at. So we'll just kind of make up a few problems and practice the graph transformation since we had some really good discussions about that earlier, okay? So there's no handout for this one, my apologies, but that's what happens when we just kind of go with the flow here. All right, so I'm gonna reshare my screen. Okay. All right, so we'll look at parent functions and graph transformation. Okay. So let's try a few examples. Let's say you had f of x equals negative x plus 2 squared plus 4, okay? So take a moment, write down that equation, and then tell me which graph transformations happen and in what order, okay? So the chat window's funny. Like sometimes when I don't have it open all the time, but when I open it, when I see like there's a notification for a new chat, sometimes it just shows like the last line that I was reading. So when I opened it, it just said no. A lot of no's. But okay, so we have an A and a C and a D. Yeah. We have an A, a C, and a D. All right. So what is the first thing that happens to this squaring function? All right, we've got a left. How about a left 2? I'll give you the left part, but left 2? Yeah. All right. So let's bring some of those colors back. We've got our C value, right? So we're +2 means we go to the left 2. Then we go to our A value. It's a negative. So we're going to look at reflecting over, whoa, x-axis, yep. And then last but not least, we're going to move that graph up 4 units. Okay. So does that kind of make sense? Like how we can look at a graph that is a function that is totally different from our exponential and our log, but the same numbers in the same places tell us the same information, right? That +2 means left 2. That +4 means up 4. Okay. So the thing here is though, when you're graphing this, you don't want to graph an exponential function. You don't want to graph a log function. You want to graph the squaring function. Okay. So let's go through and see if we can't make almost like a mini flip book for this. Okay. So I'm going to go ahead and draw a few grids. 1, 2, 3. Okay. Okay. So what we're going to do is this. We're going to go ahead and graph the parent function first, okay? So when I graph the parent function, I know that I've got my 0, 0, right? That's sort of my center point here. And I think in a parabola, it makes sense that that's the center point because it's in the middle of the parabola, okay? But then we can plot a few other nice points too. So like 1, 1, 2, 4, -1, 1, -2, 4. And so what we have here, this is our f of x equals x squared, okay? Now, the first thing that happens is we move it to the left 2. So that means that if I'm imagining this in my head, the blue point moves, not that way, Judy. It moves to the left 2 units. And because the parent function has nice coordinates, let's plot those nice 5 points. So I can go from my center, I would move everything to the left 2, right? So this point goes to the left 2, this point goes to the left 2, and then here and then here. All right. So what would the equation of this second one be? Yeah, f of x equals x plus 2 squared. Good. So f of x equals x plus 2 squared is just moving everything to the left too, okay? So we've taken care of this part in this graph, okay? So now let's go to the next one. The next one says, reflect over the x-axis. So I'm going to take this picture and I'm going to flip it over the x-axis, okay? Let's come down here for that one. Now my center point is going to stay, but all the other points that were above the x-axis are now below the x-axis. And so we could write this equation as f of x equals negative x plus 2 squared. And that takes care of the second step and gives us that reflection, okay? Now to get our final graph, we gotta move everything up 4. And so we're gonna take every single point that we had in this third graph and we're gonna move it up 4 units. So the blue dot is now up 4 units, and then everything else follows up 4 units. And then I can kind of graph the parabola. And I know that this equation is my final one, f of x equals negative x plus 2 squared plus 4. Okay. So I know that folks have been feeling like they don't really understand like which part is doing which one, or maybe how to get the final picture, because I think I've been asking you to do a lot of these steps in your head. But is it helpful to see it kind of laid out like one step at a time? Kind of imagine what's happening for each one? Okay. So on an exam, okay, all right. So on an exam, or on a quiz when you're doing the graph transformations, even though I only give you one graph, it's totally fine for you to sort of do it step by step on the side and then get your final one on the answer, okay? The other thing I want to let you know, and I don't think I've run into this problem with anyone, but sometimes people feel like there's not enough space in the quiz to like do all the writing. You can always do your work on a separate sheet of paper. Just make sure that it's sort of organized and in order so I can find your answer and your work pretty quickly. But you're welcome to do this on a separate sheet of paper if you feel like, oh, there's just not enough room on the quiz, or you want to do it all on your tablet, or you want to do it all on graph paper. Like I just provide the quizzes as a paper version just to help you out. But if you want, like if something else is more helpful, like doing it on graph paper, you are 100% welcome to do that, okay? All right, so before we move on to example 2, I want you to tell me the domain and the range of the final graph, okay? So take a moment, look at that final graph. Let's determine the domain and range before we move on. All right, what do we have for the domain here, folks? Are there any x values that you cannot put into the function? Maybe it's positive numbers, maybe it's negative numbers, maybe it's 0. No, you could put anything you want. So negative infinity to infinity. Okay. Now tell me about the range. What is the okay, so the biggest number that can come out of this function is 4, because that 4 is at the top of the parabola, okay? But I'm so glad to see that we're not writing it like 4 comma negative infinity, right? This would be wrong because we need to go from smallest to biggest. And so we want to write it the way folks are doing it in the chat, which is parentheses negative infinity to 4 bracket, okay? Now I find it really easy to do the domain and range once I have the graph. And so that's why I really want to spend a lot of time like making sure we can sketch pictures of this, because it tends to be helpful in finding the domain and range, okay? All right, let's try a couple more examples here. Okay. So let's start with this equation. F of x equals the square root of 1 minus x, and then the minus 3 is not under the square root, okay? Are you folks able to see the screen? Is anything freezing for anyone? I know for some folks it's not coming through clearly right now. Okay. It's just Brian that's the problem. That Brian, man. All right. Okay, so when we're looking at this function, one thing I hope comes immediately to mind is we see this 1 minus x, and we're thinking negative x plus 1. And then we're thinking, oh, we better factor out that b. So negative parentheses x minus 1, and then minus 3. Okay? So that kind of pattern I want us to look for with that b value, that anytime we see this, we really need to think about factor out the b, okay? Now from here, tell me what our transformations are. What happens first? What happens second? What happens third? Right 1, reflection over the y-axis, and down 3. Beautiful. All right, so we've got our minus 1, which means it goes to the right 1. We've got, we've got a negative, thank goodness for erasers. We've got a negative in front of there, so that means that we are going to reflect over the y-axis. I'm going to put y-axis in parentheses or in quotations again. And then at the very end, we have a minus 3. So that means we're going to go down 3. Okay. So let's start with our parent function graph, and then we'll start moving things around, okay? So Okay. So when we see this square root of x, I do want us to be able to plot more than 1 point, right? So we know 0, 0, 1, 1, and 4, 2. That's probably good, okay? And then we can connect those, and we get this as f of x equals the square root of x. That's our starting point. Now, if we move everything to the right one, we're going to have f of x equals the square root of x minus 1. And so that moves this center point to the right one, but every other point also goes to the right one. So this one moves over here, and this 1, 2, 3, moves here. So that minus 1 just means I'm going to slide the whole graph to the right. All right, now we're going to reflect over that y-axis. All right, that's going to give us f of x equals square root of negative x minus 1. So in this case, when we reflect over that y-axis, the thing we're actually reflecting about is right here. So if we moved over to the right one, when I say y-axis, I mean the new quote unquote y-axis. So we're at this point, we're actually reflecting about that center point, okay? So that means the center point's gonna stay, but this first black point over here is now gonna be over here because I reflected over that green line. So I've got 1 point here, and then the other one is going to be here. Okay. And then the last thing is we're going to take that whole picture, we're going to move it down 3 units. So let's see what we have. 1, 2, 3. This one comes down 3, and this one comes down 3. All right. So we've got our equation. We remembered to factor out our b, and then we're able to take it step by step to see what's happening to get our final picture. Okay? Let's go ahead and, just like we did in the last one, find the domain and the range for our final picture. Okay, so what do we have for the domain of our final picture? Yeah, so Eric, that minus sign on the inside is going to take care of that negative on the, to get some of those negative values. Yeah. So what's the smallest x value that we can put into this function? Yeah, we have to go all the way to the left end. And the biggest x value, well, it stops at our center point. So it's going to be 1. But since that is a point, we use the bracket to say, hey, we got to include this point. Okay? All right. What's the smallest y value that comes out of this graph? -3. All right. So bracket, -3, all the way. It's going to keep going up all the way to infinity. Good. Nice, Tiffany. All right. Okay. So we've got our domain and range. We've taken a look at some graph transformations. Has this been helpful to maybe clear up some of the, like, why we're doing all the graph transformation and how in the world it applies to like a bazillion different functions? Okay, good. That's the goal. All right. So I'm going to stop sharing my screen for a moment. Nice, good, okay. Let me stop sharing my screen for a moment. Okay. So here's what we're gonna do for the remainder of class, okay? So I'm gonna make a few modifications. I think we're all here, so there shouldn't be anyone who misses this announcement, but let me type it into the chat just so we have that as well, okay? So update number 1. Quiz 3 is still due on Wednesday at 9:30 a.m., but only do numbers 1 through 4. Okay? So there are 10 questions in there, only do numbers 1 through 4. If you want to do the other ones, like you want to try it, definitely give them a try. I think it's not bad to kind of prepare for Wednesday's lecture and also study for the exam, but the ones that I will be grading will be numbers 1 through 4. Okay? So the numbers 1 through 4 should reflect the graph transformations and the parent functions that we did. So the chapters, it says at the top of the quiz, it should say which sections are covered in it. Okay? So parent functions in 4.6 for quiz 3. All right? So I don't think parent functions is like a chapter in the book, which is why it doesn't have a number that goes with it, but you can probably find information on it from like different sections in the book collectively. Okay, so that's update number 1. Yeah, that's the exam. Okay, so update number 1 is quiz 3 still due at 9:30 on Wednesday morning, but only do numbers 1 through 4. Okay, update number 2 is a reminder from earlier that if you want to resubmit quiz number 2, the last 2 questions, right? So those are the graphing ones on the log. Please email me your PDF and I will update your grade. Okay? So if you were like, oh man, I can't believe she made us do those 2 questions and then she took off points and we didn't even learn it yet, but now I feel much better about it. If you want to resubmit that to me, please email me your PDF and I will update your grade. And let's say email those to me by Wednesday at 9:30 a.m. Okay? So quiz 3, only 1 through 4. Quiz 2, 9 and 10 if you want to redo it, okay? The last update, yeah, that's exactly what we're gonna do right now. Update number 3. Well, it's not really an update, but I'm gonna leave the rest of the class time for you to work. The rest of class time is for you to work on class 3, Okay, so let me just hang out here for a moment. You've already been put into groups for your discussion. So there should be like a discussion board that you can click on, but it's only with a few of your classmates. And there are some directions on that. Okay, so let me just go ahead and share my screen so we can take a look at that classwork. Okay, so if we go to assignments, that's where you can find the assignments, right? And we're gonna go to classwork 3. So that's due by 1 o'clock today, all right? It shouldn't take you that long, but you're gonna click on classwork 3. And again, you're already in a group for certain discussions, but I want you to answer the following questions, okay? So number 1, I want to hear how you typically prepare for exams, all right? Number 2, I want you to list 2 specific things that you will do individually in order to prepare for this week's exam, all right? And then I want you to list when you're going to do these things. So like, when are you going to, not like, oh, I'm going to look over my notes at some point, but like, no, tell me like, when are you going to do what thing, okay? I want you to list 2 specific outside resources. Outside meaning not you and your brain, but it could include other people, it could include office hours, it could include study sessions, or STEM tutoring or a study group, but tell me when you're going to access these groups, okay? Then what is your favorite snack and why? Because I think snacks are fun and I'm curious. So you're going to answer those. Then after you've posted your response, I want you to respond to your group members' posts, okay? It doesn't have to be a very long response. It could be like, ooh, that's a great idea, or that's my favorite snack too, but I just want you to, you know, interact with each other a little bit on this discussion board, okay? Let me actually bump that to 1:30 to kind of give us just a full hour to do this in case we want to, you know, go eat lunch or go to the restroom or anything like that, okay? So that is what the rest of class time is for today, and I'll bump this deadline until 1:30 just so we have a little bit more time, okay? Are there any questions about the discussion, the classwork for today? So you're going to, yeah, hit reply and it should generate a response, okay? Or a place for you to respond. I know a couple people have already done the discussion or started it. Is that what you had to do in order to access the discussion? Yeah, okay. Cool. So I'll give you some time to go work on that. And one last announcement before we finish up here today. Where's my notebook? Okay, so in terms of Val's sessions, I just wanted to let you know what she's going to be going over today and on Wednesday, okay? So for Val's sessions, and let me put this in the chat, so Val's Monday session, here's what she's going to go over. She's going to go over quiz 3 if you need any help on that. She's also going to start to talk to you about creating your reference sheet for the exam, okay? I think that is going to be one of the most important ways in which you prepare for the test is having a good reference sheet, okay? So quiz 3 and the reference sheet are going to be her main points of focus, but she said that you guys have been so awesome at bringing questions. So if you have questions that are not related to those, don't be shy, go ask them anyway. She is very happy to go with the flow if there are other things that you have questions on, okay? So it could even be like reviewing last week's stuff or even previewing Wednesday's information as well, okay? So that's her Monday session. Val's Wednesday session, all right, she's gonna go over quiz 4. Gonna take any questions on chapter 4 in general, and also talk about helping you make your reference sheet, okay, for that. And if you wanted to take a look at the web assign homework for week 2, I'm sure you can also ask her questions about that, okay? Would it be helpful to put like what she's going to be covering in her sessions in the La Semana for the week? Is that a good place to put it? Yeah, okay. All right, cool. So I will make sure to include that in the La Semana. I'll go back and put those in there in case you missed these announcements, so you can go back and find them, okay? All right, so folks, go off, have a discussion, tell each other how you're going to study, but more importantly, tell yourself how you're going to prepare for this exam. I want it to be a positive experience for you. I think you've all been working really hard, and I want that to be reflected on the exam, okay? So I'll hang around for a little bit in case anybody has any questions, but you're welcome to peace out. And if you go into the Canvas, it's already populated for you. I don't actually know how you know who's in your group though. But you'll see as soon as other people start putting their responses up. Like, I think your answer only goes to the people in your group. All right, I'm going to stop recording.